Hey guys, we are going to begin working on probability. So our goal today is to find the probability of simple events and its complement, okay? So how do you find the probability of simple events? We're going to be dealing with that question also. So we're going to deal with some vocabulary first. The chance that an event will occur, we call that probability. Then we have one outcome of a collection of outcomes, and we call that a simple event. We're looking for one thing to happen, okay? Then we have any one of the possible results of an action, and we call that an outcome. And we will kind of talk about these in a little bit more detail in case you're confused, okay? And then the set of all possible outcomes, we call that the sample space, okay? I normally refer to your sample space as your list. If I'm abbreviating this definition, it's a list of all the possible outcomes, okay? So let's move on, and we will kind of discuss this a little bit further. So, for instance, when you're rolling a number cube, okay, we have 6 sides, but we don't say the sample space is 6. We say the sample space is 1, 2, 3, 4, 5, 6. When I list out this sample space for the number cube, this is going to help me find my probability, okay? And then finally, this is super important, guys. Opposite events adding to 100. We call these complementary events, okay? So complementary, you see it twice in math. One of them has to do with angles that add up to 90. Complementary events add up to 100%. So here's an example down here of complementary events. It says, suppose there is a 10% chance of rain today. Okay? The complementary event will be what is the chance that it will not rain. I normally write it like this, probability not rain. Okay? So, again, when it says rain, opposite, I don't say it's sunny. Opposite is it is not going to rain. Okay? Because if it doesn't rain, it might be sunny, it might be cloudy, it might snow, it might hail, we don't know. But the opposite event would be not rain, okay? So if there's a 10% chance of rain, then the rest of it is 90%. How do we get that? Well, there's a 100% chance it's either going to rain or not rain today, 100% chance. So if there is a 10% chance of rain, which actually this morning I looked and there is a 10% chance of rain, then there is a 90% chance that it will not rain, okay? So our events should add to 100% or one whole, okay? So right now, guys, they might say complementary events, or they might say find the complement, find the probability of the complement, okay? Just so you know. Basically, when they're saying that, you're thinking of the word not. Please write that down. Okay. B, the chance that Carl is chosen to represent his class in the student council is 0.62. What is the probability he will not be chosen? Okay. So I don't generally like expressing my probability as a decimal. I usually use it as a percent or a fraction, okay? But they're giving it to us this way. So first of all, 0.62, that probability means 62%. If I move that decimal 2 times to make it a percent, okay, when I'm giving it back that 100, it will be 62%. But the probability he will not be chosen, I'm going to leave it this way, is we would take it away from one whole instead of 100%. Okay? Minus, sorry, my pen gets messed up. Subtract that, and hopefully you know that will be 10, this will be 9, that will be 0. So we get, this is our probability that Carl will not be chosen, okay? So basically 38% chance that he will not be chosen, 62% chance he will be chosen. Okay, so letter C, there is a 7 out of 25% chance of getting a red gumball out of a certain machine. What is the probability of not getting the gumball out? Okay, and again, they may ask it different. They may say, what is the probability of the complement of that event? Okay, so I want red. Well, this was red. We want not red. Okay, so 7 out of, and again, there's a couple ways that you can do this. Okay, there's a 7 out of 25% chance, 7 out of 25 chance of getting a red gumball. So what I would do, this is me, is I would say, okay, well, if there's 7 chances of getting a red, how many chances is there of not getting a red? And I would subtract it. This pen is making me crazy. Okay, when you subtract, that means 18. There are 18 chances of not getting a red. Okay, so I would say this is, again, this is a good enough answer. I can put 18 out of 25. They gave it to me as a fraction. I'm going to leave it as a fraction. Now, if I wanted it as a percent, I would compare it to 100. And either A, cross multiply, or B, find that relationship. One of the two. Okay? So right now, your big idea is the complementary events. Okay? I want you to be able to write a sentence about complementary events. How can you identify them? Okay? And we're going to move on to the next part. This is not a summary, by the way. I'm just leading you off. Your job is to write the summary. Okay. Now, when we do probability, guys, we always want to make sure that we put that total on bottom. Okay? And normally they put our however many chances we have for the desired outcome. Okay? Okay? So this says Becky is rolling a number cube with numbers 1 through 6. What is the probability she will roll a 4 or a 5? We want to look at this word or. Okay? Either one of those is something that we want. Okay? This is still a simple event. We're going to roll the number cube one time. Okay? So this is a simple event. Okay? So I want the probability of a 4 or 5. If I see and, that's changing this up. Okay, because that's telling me I'm rolling it more than once. Okay, so my sample space, guys, 1, 2, 3, 4, 5, 6. My outcomes, I have 6 of them. Okay, that goes on bottom. Now I want a 4 or a 5. I want a 4 or a 5. How many chances do I have of getting a 4 or a 5? Hopefully you know I have 2 chances, okay? 2 chances. Now I need to simplify that. I can already tell that one is incorrect, okay? What do I get? Okay. Now, number 2. If the probability of an event occurring is 0.4, what is the probability of the event not occurring. There should be a T there. I didn't even make this one. This was a mistake I already put in. Okay, so remember, our probability basically is 100%, okay? One whole, okay, the total. We have the chance of it occurring or not occurring. Together, they add up to one whole or 100%. So if the chance of the event happening is 0.4, then my goal is just to subtract it. This is how I find that opposite event. This is talking about complementary events. Okay? So what do we get when we subtract this? Hopefully you know 0.6. Okay? So Sandy spun a spinner with 5 equal parts, labeled 1 to 5. What is the probability she will not spin a 4? So again, guys, I like to do this. Probability of not 4. Okay? So we're kind of talking about complementary events here. Okay? So we have my spinner. It has 5 equal parts. My sample space is 1, 2, 3, 4, 5. Okay? I do not want a 4. I want everything else. So how many chances do I have of not getting a 4? Well, I have 4 out of 5. Okay? I don't see 4 out of 5 here. Luckily, I'm not seeing 45% because some of you would choose that. So guys, if it says 4 out of 5, that means, let's just change it to a percent. That means, remember, we compare it to this magic number. Okay? What's that? If you already know 4/5, by the way, that's fine. Divide by 5, divide by 5. Five into 40, 8, 40, 0. I'm not done. 5 into 0, 0. So 80%. So that would be A. Okay? So hopefully we're kind of getting the gist of this. Now let's look at this last one. I don't think we will have a chance to do both. Let's see. A bag contains 9 red, 10 blue, 6 green tiles. A tile is randomly drawn from the bag. Which statement is true? So I'm just going to write this out. I have 9 red, 10 blue, 6 green tiles. Okay? The probability of drawing a red is 36%. And the probability of not drawing a red is 64%. The one thing I will say is I can tell these two add up to 100%. So to figure out the probability of a red, I would have to do 9. I would have to have my total, right? My total, which is 9 plus 10, which is 19, plus 6, which is 25. 9 over 25. And I compare it to 100, right? So times, or I could cross multiply, but I see a relationship this way. 25 times 4 is 100. 9 times 4 is 36. Okay, so this one looks like my best answer. Okay. And if I had time, I would go on and disprove the other ones, but let's go on and do number 5. A nickel and dime are flipped. What is the probability both coins will land tails up? Now, in order to do this, we need to draw a tree diagram of our outcomes. So I have a nickel. If I flip the nickel, I can get heads or tails, correct? Now, if I get heads on the first one, I can get heads on the dime, right? Or I can get tails on the dime. So hopefully this looks familiar. Hopefully you've done something like this. But I might get tails first. If I get tails first, I could get heads and then tails. So there's actually 4 total possibilities here. Okay? And my outcome that they'll both land tails up would be 1 out of 4, which is 25.